This is part 1 for the chapter test review. So for number 1, they're asking us to simplify. We know the square root of x squared is going to be x, but the square root is 72. I want to break this up into the perfect squares. Like I talked about before, if you saw 72 and 9 and 8 jumped out, like the square root of 9 times the square root of 8, I can write this like 3 square root 8. But remember, if we can simplify, we should continue to simplify. So I can write this like 3 times the square root of 4 times the square root of 2. So 3 times 2 square root 2, or 6 square root 2. So altogether this looks like 6x square root 2. So it doesn't matter, like if you knew right away that we could write 72 as 36 times 2, and then take the square roots, you'll also arrive at 6 square root 2. And number 2, we're trying to simplify the cube root of negative 256. So negative 256 is going to be 64 times 4. This is 16 times 1, 256. So if I was going to write this like the cube root of 64 m cubed times the cube root of 4. The cube root of 64 is 8. The cube root of m cubed is m, and it's 8m cube root 4. For number 3, it's asking us to write the exponential form. In the exponential form, so we have a rational exponent. Remember to write the parentheses around it. If it's the 5th root, that's in the denominator, and raised to the 3rd is going to be 3. We could also write this like the 5th root of 3n raised to the 3rd power. I personally think it's easier to work on it this way here with the 3n, but that's me. For number 4, if I have v raised to the 5 halves, it's going to be the square root of v raised to the 5th. And again, you could also write this like the square root of v to the 5th. In numbers 5 and 6, we're going to write these as the in our radical form and then actually simplify it. So this looks like the cube root of 27a to the 9th, and then I would square this. I think it's going to make our lives a lot easier. So the cube root of, this is going to be 9a to the 9th times the cube root of 3 squared. This is 3a to the 3rd times the cube root of 3 squared, or 9a to the 6th cube root 9. For number 6, it's the square root of 64x squared, or 8x squared. And number 7, they're asking us to simplify the answer so that it only contains positive exponents. 3 over 4 isn't going to be simplified. If it's going to be a positive exponent, we're going to keep x to the 4th in the denominator. You could write this as 3 times x to the negative 4. But when we're dividing, we're going to subtract the exponents. So it's like y to the negative 3 minus 4, which is y to the negative 7. If it's negative 7 in the numerator, I can write this as 1 over y to the 7th in the denominator. All right, when we're multiplying, we add the exponents. So 3 times 4 is 12. If it's y to the 1st times y to the 5/3, 1 plus 5/3 is 3/3 plus 5/3 to get 8/3. So 12 y to the 8/3, and then x to the, or it's 1/2 plus 3 1/2 plus 6/2 x to the 7/2. When we raise like a to a power, if I have a to some number, b to some power, raised to another power, I don't know, d, we're going to multiply the exponents. So here when it's x to the -2 raised to the 3/2, I'm multiplying -2 times 3/2 to get x to the -3. Again, they're asking for only positive exponents, so I'd write this as like 1 over x cubed. Y to the 1/4. Sorry, y to the 1/4 raised to the 3/2. I'm multiplying 1/4 times 3/2. Sorry, that should be a 2. This is 3/8. So y to the 3/8 in the numerator over x to the 3rd. Okay, and number 10, if we're simplifying, this is the square root 2 square root 2 divided by 3 square root 25. The square root of 25 is 5, so it's 2 square root 2 times 3, divided by 3 times 5, or 2 square root 2 over 15. I would rewrite this one like the square root of 15 divided by 27. You can simplify the square root of 27, but I think it's easier here to simplify. Rewrite this fraction as 5 over 9. Right, if I divide both 27 and 15 by 3. And this will equal to the square root of 5 divided by 3. And number 12, we can combine the like radicals if they have the same index, which all of these are square roots. We don't write the 2 there, but we know that this is the square root here. And they need to have the same radicand, or what's left inside the radical. So I can't simplify -3 square root 6. But I can write this as 2 times the square root of 4 times the square root of 2 minus, and this is going to be the square root of 4 the square root of 4 times the square root of 6. So -3 square root 6, this is 2 times 2, so it's plus 4 square root 2 minus 2 square root 6. These are like radicals, so if it's minus -3 square root 6 minus 2 square root 6, this is -5 square root 6 plus 4 square root 2. Same idea in 13. Now, you don't have to simplify these beforehand. We can say that this is going to be -1 square root 45 plus 2 square root 6. I can rewrite the square root of 45 as 9 times the square root of 5 plus 2 square root 6, or -1 times 3 square root 5 plus 2. Sorry, I didn't mean to write a 2 there. Or -3 square root 5 plus 2 square root 6. In number 14, we're going to distribute when we multiply the radical. So this is the square root of 2 times the square root of 3 plus the square root of 2 times 3. We can multiply inside the radicals the square root of 6 plus 3 square root 2. All right, I think I'm going to call it at this point and say this is the end of part 1. I'm going to make a second video for part 2. There's also the practice online on my math lab for another version of the test practice. And if you have any questions, feel free to email.